this is just a quick run through of the data structures and algorithms playground that I've been working on. So you can see here we've got a nice table of contents. I'm going to the fishing shuffle, and for some reason there's a bug at the moment with Xcode, but if we add this back in, we should see the live view. Okay, so we can go through now. Let's just do a bubble sort. You can see the animation here going through, showing you how the bubble sort actually works. And then at the end here we get a count of the number of iterations that have actually been processed in the during the algorithm. So here 9,900, array length of 100, so it's about 100 squared would be 10,000, so it's 100 off 10,000. So alternating bubble sort now. So this is one where instead of sorting always from bottom to top, it will sort bottom to top, and then top to bottom, and then bottom to top, and then top to bottom. Insertion sort. And then a shell sort. So this is an insertion sort working over different gap lengths. I'm fairly new to this myself, but it works. It seems to work quite well. The reason it's going so slowly is because I'm running on a MacBook Air and trying to record the screen at the same time, so it's not actually this slow when I'm not recording. So you see now it's working over a gap of 4, and then it should go over a gap of 1 now. Next is selection sort. And next a merge sort, so this is where we get into the efficient sorts. So you see this is breaking the task down recursively into smaller and smaller sections. Oh, come on, don't die. Okay, so that's, yeah, it's starting again. My MacBook Air is not enjoying this at all. If it does it again, I'll just skip on to the next one. Okay, oops. Now we have a heap sort. So this is where it first sorts the information into a binary search tree structure within the array, and then it just takes the first value, which is always the first item in the array is always then the highest item in that array. And it takes that one and moves it to the end. So you see here it's sorting it, and then here it's taking them from the front and putting them to the back. And every time it takes one from the front, it then then makes sure that the binary search tree is in the correct order again. And you see here this, where before we were getting around 10,000 iterations, this one has 500, so it's a lot more efficient. And then quicksort. Okay, let's start this one again. So this one chooses a pivot value within the array and moves everything lower than the pivot before it and everything higher than the pivot after it, and then it splits it down again and again and again. And again, this one, 600 iterations, so this is the same n log n as the merge and the heap sort. The next one is a bit of a different one. It's a binary search tree, binary tree. And this one just creates the tree and then prints it out. Nothing too complicated there. It just prints the tree out. So I'm going to add a self-balancing binary tree as well. And you can see here that the tree is not balanced at all. As there are some branches with only 2 or 3 levels deep, and then some where you've got almost 5 or 6 levels. So a balanced tree tries to make has the minimum depth possible for all of the leaves. So anyway, that's I'll put a link in the description of how you can get hold of this. And if you've got any suggestions on what I should add next, let me know in the comments. Thanks.